Ladies and gentlemen, welcome to today's lesson. Good afternoon. I hope you are fine. I hope you have had a good week and a fantastic one. Nataka nichukue nafasi hii niwakaribishe nyinyi wote wale wametune na wale bado watatune, mjisikie huru. This is Chemistry Wednesday kama kawa by Teacher Kirwa, a teacher of chemistry biology. Ninawakaribisha muendelee kuona, muendelee kulike, muendelee kushare. My YouTube channel is Teacher Kirwa. Hit the red button to subscribe na uweke pia kengele ikue on so that wakati wowote I put a video there you can access it. As we speak, our last lesson that was on Wednesday last week is already on YouTube. You can go there and then you view. We have done a lot and there are more videos that are clearer in that YouTube. So this is Facebook Live. The page is Shadrach Kiprotich Kirwa. You can always find the videos also here. I am deeply indebted to you for having watched my videos up to 1,000, 2,000 and even more views as time goes. So I am happy for that. Let us help each other to saidiane kukua. As you benefit from these lessons, I also benefit from your view. Okay, I benefit from your like, and with time Mungu ataenda kutubariki sisi wote. So today is 26th of August 2020. I want us to do a recap on what we have been doing for the last 2-3 weeks. That is on alkanols. So I want us to just remind ourselves, no much ado, just remind ourselves of what we have done so far, and I hope all shall be well. So leo hautalala darasani, chukua kalamu yako vizuri, tutafanya maswali 2-3 in this textbook, course book, that is KLB Form 4, page 177. There is an exercise there on that page that I just want us to go through, and then we summarize our lesson for today. So it will be as short as that. Now, so this is just a recap lesson on alkanols and what we have done. So when we looked at alkanols, we started by looking at nomenclature. So if you like, you can call it recap lesson on alkanols. So we started by looking at nomenclature, how alkanols are named, and we said alkanols contain a functional group OH, which we call it all. Functional group is OH. And we said a functional group is a group of atoms that characterize the chemical reactions or chemical processes of organic substances. So that is OH. We say the general formula for alkanols, general formula is CN H2N plus 1 OH, where N is the number of carbon atoms. The other thing also we said on nomenclature is that you replace the E in alkanes. So for alkanes, you replace the E with OH, so that instead of alkanes, you have alkanols. So that is as simple as that. And then so you have methanol, ethanol, propanol, butanol, depending on the number of carbon atoms and the prefixes that we gave when we were doing organic chemistry 1. So that is what is so important for you to note. Number 3 also, something else that we've discussed is the preparation of before preparation we have isomerism in alkanes. Okay, so we have isomerism in alkanes. We talked about isomerism in alkanols, and we said alkanols exhibit 2 types of isomerism. It exhibits branching isomerism due to the presence of the branch, and then we also said it exhibits positional isomerism. Okay, positional isomerism due to the position of the functional group. You can have butane 1-ol, butane 2-ol, depending on the position of the functional group. So that is important to note. Then we talked about preparation of alkanols. Preparation of alkanols, we said alkanols are prepared by one method of preparing alkanols, we said, is the oxidation of alkenes. When alkenes are oxidized or they undergo oxidation using potassium manganate 7 or potassium dichromate 6, what we said is when it undergoes that process, then it forms an alkanol. So that is it. We also have hydrolysis. Hydrolysis is the opposite of dehydration. Hydrolysis is a process undergone by alkenes. So alkenes undergo hydrolysis, that is in presence of sulfuric 6 acid and few drops of water and then warmth. So when they are warm, they undergo hydrolysis. That hydrolysis leads to formation of an alkanol. We also discussed the properties of chemical properties of alkanols. Chemical properties. And among the chemical properties, we talked about combustion. Okay, I think we still have them here. I'm just highlighting what you are supposed to get. So we talked of combustion. Okay, we talked of reaction with metals. These are the chemical properties we discussed. We have combustion where it burns to give carbon dioxide and water, and then we have reaction with metals to form an alkoxide, for example sodium ethoxide, which we said is a base which hydrolyzes in water to produce hydroxide ions. We also talked about reaction with sulfuric 6 acid. We talked about oxidation. Okay, so we have properties like oxidation. Okay, we have reaction with sulfuric 6 acid, which is actually dehydration. This one is called dehydration. We also have a reaction with metals. Okay, we have reaction with metals, as we said, to form an alkoxide. And then we have the most important one we did is esterification. And we said esterification is where an alkanol reacts with an alkanoic acid to form an ester. And we gave an example of this, and we said an ester is a sweet smelling substance found in I gave you an example that is found in a banana. So that is it. So I want us to go through a few questions on the same at the end of the exercise, and then we call it a day. So the first question here is draw the structures and name the alkanols with the following number of carbon atoms. Draw the structure and name alkanols with the following number of carbon atoms. The first one is 6. 6 carbon atoms. B is 7 carbon atoms. C is 10 carbon atoms. So you are supposed to draw and name the compounds ending having these properties. Okay, now for you to be able to draw this and name these compounds, one thing you need to note is the general. For you to draw and name, so this draw and name. Now for you to draw and name, then you need to know the general formula. So we have said the general formula is CnH2n plus 1 OH. So if n is equal to 6, okay, you just replace or substitute. If n is equal to 6, then you will have C6H is 2 times 6 is 12 plus 1 is 13. So C6H13OH. As simple as that. For you to draw, you take 6, C is 6. So 1, 2, 3, 4, 5, 6. You know you must have an OH. So let me put my OH there. The remaining bonds, you fill the bonds using hydrogen. So this 1, 2, 3, 4, 1, 2, 3, 4, like that. So that is how you do it. So you have C6 hydrogens, you count, there will be 13, and then OH. So this one is where n is equal to 6. Now we said the prefix when n is equal to 6 is called X. The prefix is X. Now because it is an alkanol, then you call it hexanol. Okay, so that is hexanol. The rest, n is equal to 7, you can substitute from the formula. So 7 is C7H15OH and the rest. So where we have 7, then 7 is called hept. 7 has a prefix hept. So if it is n is equal to 7, then it is heptanol. You just replace the heptane. It was supposed to be heptane. So you replace the E with OL. So that is it. So you can draw heptanol. You can draw this. Where n is equal to 10 is decanol. Question 2. So I'm just using, I'll do 1 or 2 questions in each because they are A mpaka E. So sitafanya yote, ndakufanyia tu moja ama mbili alafu utaendelea na zingine. Number 2. Draw the structural formula for each of the following compounds. The first one, is pentan 1-ol. Pentan 1-ol. Pentan 1-ol. Now, when we are drawing, first of all, as we did with the organic chemistry 1, pent means 5. Okay, pent is 5. So draw 5 carbon atoms. So pent is where n is equal to 5. So draw 5 carbon atoms. So you have 1, 2, 3, 4, 5. You are through with pent. Now you want to draw all, so that is, this name tells you you have 5 carbon atoms in this alkanol, which is called penta, and then you have OH at carbon number 1. So at carbon number 1 you have OH, and then you complete the rest using hydrogen. So that one is called pentan 1-ol. If you like, somebody else can put this OH instead of here, you put it at this point. It's still correct. So that was A. Let me do number B, and then I go to E. B says butan 2-ol. We want to draw butan 2-ol. The same way, but refers to 4 carbon atoms. So but is 1, 2, 3, 4. Okay, and then all at carbon number 2. So 1, 2, you put all there. Okay, and then you complete the bonds using hydrogen. So hydrogen there. You complete the tetravalency of carbon using hydrogen. That one is called butan 2-ol. Number E is 2,3-dimethyl pentan 2-ol. 2,3-dimethyl pentan 2-ol. Okay, such a long name. Okay, lakini niliwaambia you don't worry with the name, just look at the parent. All right, the parent here is pentan 2-ol. So draw pent. Pent means 5, and then 2-ol. So you have 1, 2, 3, 4, 5. Then 2-ol. At carbon number 2 you have OH. That is parent. We have drawn the parent. Okay? Yani tumechora mzazi. Baada ya kuchora mzazi, tunawekea nini? Branch. So this is a parent. Now put the branches. So you have at carbon number 2. Di means 2. Di is 2 methyls. So you have 1 methyl at carbon number 2, another methyl at carbon number 3. So here you have a methyl. Methyl is CH3. You draw it open like that. And then at number 3 also, you have another methyl. Anything else? No. So we have drawn, this is at carbon number 2, you have a methyl. Carbon number 3, you have a methyl. Methyl is CH3. And then at carbon number 2 again, you have the OH. Now, having done that, you complete the tetravalency using hydrogen. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. This carbon is full already. This one is 1, 2, 3, remaining with 1. This one, that, and that. So this is called 2,3-pentan 2-ol. So that is it. Number 4 says an organic compound with a molecular formula of C5H12O shows 6 different isomers. That is C5H12O has 6 isomers. Draw the structural formula for each of the isomers. Name each one of them. Now, this one is C5, okay? So, we know we are talking about alkanols. So, definitely, there is a O and OH group here. So that means because it is we are talking of alkanols, then we have OH. Now this conforms with our formula CnH2n plus 1 OH. What happened here is that this OH, this H was taken here. For example, the formula it will be C5H11OH. Okay? If you have C5H11OH, what this person did is that he shifted, he or she, okay, whoever wrote this book, took H and brought it here so that you have 12. Okay? Otherwise, it is still the same. So you have C5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You have an OH there. That is number 1. Isomer. So isomers. Isomerism. So this is one isomer. It is called pentan 1-ol. So this is pentan 1-ol. And then you go to the next. You can do positional isomerism. Take this to carbon number 2. Okay. So if you take OH to carbon number 2, you have 1, 2, 3, 4, 5. Bring it here. The rest will be hydrogen. These ones are hydrogens. Now, this one will be called pentan 2 all. Okay, this is pentan 2-ol. It is still having C1, 2, 3, 4, 5. C5. H is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ukipenda uongeze hiyo ni 12. So it is still C5H12O. Now this is pentan 2-ol. You can still take the OH to carbon number 3 so that you have number 3, 5. You take it here. So you have OH there. The rest are hydrogens. Okay, the rest are hydrogens. Now this one is pentan 3-ol. Hizi ndio tulikuwa tunaita positional isomerism. Positional isomerism kwa sababu this OH is at different carbon atoms. So those are 3. Now number 4, you can come back here even. Take the last carbon atom. The last carbon atom, bring it to carbon number 2. Okay? So that you have 1, 2, 3, 4. You have OH here. Now we are transferring this carbon atom to carbon number 2. So here you will have a CH3. CH3. And then the rest are hydrogens. Okay, so here you will have 1, 2, 3, 4, 5. Okay, you still have C5. Hydrogens, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is still the same. Now, naming, the parent name, the longest carbon chain is 1, 2, 3, 4. So the parent name is butan 1-ol. Butanol is a butanol. But now the branch at carbon number 2 you have a methyl. So at carbon number 2 you have a methyl branch. The name becomes 2-methyl butan 1-ol. Right? So the name is 2-methyl butan 1-ol. To say at carbon number 2 you have a methyl branch and the parent name is butan 1-ol. Mind you, you can, if you write it in that, it is still the same molecular formula, C5H12O. That is number 4. Number 5, you can go on and on. Now you have taken at carbon number 2, you can still take the last one and bring it to carbon number 2. You can still take this and bring it here. Yeah, you lack 1 here. Okay, so let us lack 1 that for those people of the mouth. Okay? Those people of the mouth. So you will have that's number 5. 1, 2, 3. Now you have a CH3 here. You have another CH3 here. Obviously, we have an OH there. Okay? Fill the rest using nitrogen, so nitrogen's there. We together. 1, 2, 3, 4, 5. C5. Hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. Then O. Like that. Number 6. So the name of this, you have 1, 2, 3. So the parent name is propan 1-ol. Propanol, because it is 1, 2, 3. Now you have branches. You have 2 methyl branches at the same carbon atom. So you have 2 dimethyl. Okay, you have 2 methyl. So 2 dimethyl. So the name becomes 2 dimethyl propan 1-ol. 2 dimethyl propan 1-ol. So that is it. Now number 6. This customers ni ujanja tu yako, unaona bado inatosha kuweka wapi. Okay, now number 6. But there is something I did not mention. This one is because this is pentan 1, this is a primary alkanol or primary alcohol. This is secondary, and this one is tertiary, number 3. So primary, secondary, tertiary. Now here still you can do number 6. Number 6 unachukua hii unaleta hapa. Okay, so there are so many of them, so those are 5. You can go to the others. Now number 5, question 5 says esters can be made by reaction of many different types of alkanols and alkanoic acids. Esters can be made by reaction of different types of alkanols and alkanoic acids. You remember we said that one is esterification. Question A. Write an equation for the reaction between methanol and ethanoic acid. So methanol and ethanoic acid. Methanol, we said methanol, this is N is equal to 1. No, yeah? Yes, N is equal to 1. So you we have the general formula is CnH2n plus 1 OH. So if it is N is equal to 1, then you have methanol is CH3OH reacting with ethanoic acid. Ethanoic acid also, we said this one is CnH2n plus 1, and then you have COOH. Okay, so ethanoic acid is where you have 2 carbon atoms. Now you have, so this one will be CH3COOH. So this is methanol, this is ethanoic acid. You have 2 carbon atoms. Now when we learn alkanoic acids, we have not done that. When we do alkanoic acids, the first member we will say is where N is equal to 0. Number 1, huyo ni methanoic acid. Ethanoic acid is where N is equal to 1. Okay, yani N is equal to 1 because this C here is a must to be there. We shall discuss that. So methanol and ethanoic acid, when they react, you have the following. You remember we said tulisema hii inaenda na hydrogen moja, ndio? This one takes that last hydrogen so that you have water. So this one is H2O. Now the remaining part we said you write hii inaitwa ethanoate. Ethanoate from the acid. And then this one is, now because it has lost OH, we are remaining with CH3 inaitwa methyl. Okay, so you write the formula beginning with this. So you have CH3 COO then CH3. So hii inaitwa methyl ethanoate. Methyl ethanoate, which is an ester. So huyu ni ester, anaitwa methyl ethanoate. So write the equation between that. Draw the structural formula, ndio hiyo. Number B ya mwisho. This was Roman 1. Roman 2 is a reaction between ethanol and butanoic acid. Ethanol and butanoic acid. Ethanol is where N is equal to 2 na tunataka hii. So it is C2H5OH. Okay? Ethanol ni pombe. Ukimwaga pombe na kuangalia vizuri, utaona hii formula. Utaona C2H5OH. Yeah, ukimwaga pombe. You can try that. Okay, so you have C2H5 OH. Now plus butanoic acid is, you have 4 carbon atoms. So this is where N is equal to 3. So N is equal to 3 here. You will have C3 H 2 times 3 is 6 plus 1 is 7. So H 7 and then COOH. This butanoic acid. Now what does it give you? You remember our thing? You take this and hydrogen. Okay. Then you have, so this you will remain with C2H5. This is C3H7COO. This is ethyl because it has 2 carbon atoms. So this is ethyl. This is butanoate. Ilikuwa butanoic acid, so itakuwa butanoate. So butanoate. Now what is the product? So the product will say, you draw this and then followed by that. So the product is, apart from water, you have water there, and then so you will have C3H7COO C2H5. So that is the product. This one is called ethyl butanoate. Sawa? So that one is ethyl butanoate, and then marks the end of that. So that is just a recap of what we were doing. We have done those 5 questions on that particular page. I mean, yeah, the 5 questions. You can attempt the remain. There are others that we have not done. You can attempt them at your own time. So that is that. I want to take this time now to say that our lesson has ended there. Yeah, yani lesson imeishia hapo. I want to wish you well. I want to wish you a good week ahead. In our next lesson, by the way, we are considering doing biology. So don't be surprised next week. We might jump into biology kidogo, but we'll still communicate. And then when we come back, we continue with alkanoic acid. So we are remaining with alkanoic acid or carboxylic acids, and then we do polymerization, na pia kuna soaps, detergents, that is. So so far so good. I want to say thank you for tuning in. Thank you for having watched the video. I'm grateful for that support that you've given. Keep commenting, keep liking, and we shall be okay at the end of the day. So Mungu awabariki sana wapendwa. Until next time when we meet again, may God bless you. Bye bye.